and I'm going to shake the cell. So okay, so now we got to the point that we have 0.002 cc's of gas. That's the smallest amount of gas that we can detect. And at this time, the pressure is 773.31. So I got the bubble point, and then I'm going to use F10. I'm going to use F10, and I'll get the composition. So now the N-butane liquid is almost 10%, 0.1062. The N-butane gas is 0.0415. And I know 1 minus that is this, and 1 minus that is that. So I have liquid 89% in the gas, in the liquid phase, and 95% in the liquid phase, in the gas phase. So I got these two numbers as well. So the rest of these mixtures are exactly the same as this, and I'll provide you with the full table to just make the video shorter. Now, what we are going to plot is actually we are going to plot the pressure, okay, versus, so this is going to be CO2, so I'm going to plot the okay, let's select the data. I'll select the data. So this is going to be my bubble point line. So the X values is the composition of the CO2, and Y value is my pressure. So X value is composition of the CO2, and Y value is my pressure. Okay. So I got my, and I can connect these. So this becomes my bubble point line, and I can add my dew point line as well. So dew point line, again, the x-axis would be, for the dew point line, the x-axis would be the composition of gas CO2, okay? And y-axis is still my pressure. Okay. So I have my dew point and I have my bubble point line. So, and let me just add the axis, my horizontal axis is, that's a CO2 percent, CO2 mole fraction. And y-axis is my pressure. And PSI 8. Okay. So what I'm going to do, I'm going to complete this table with the rest of the information. But what we need to also do is, as I said, for one of the points here, I need to have some, because this is far away. These 2 points, the first point, second point, and this is my last point. These two are far away. So I need to have one point here, one estimate of the dew point. Because remember, I haven't used the dew point information. I found the bubble point and I used the saturated liquid and saturated gas composition of the CO2 at the bubble point to generate this curve. But for one point, I need to have some idea. So how do I get that point? Okay, to get that point, I'm going to skip the program. So if you go to the lab number 2, saturation pressure, it says, okay, it says for one point, okay, we need to have the dew point. And for that point, I'm going to use a smaller amount of liquid. Remember, originally we had 10 cc's of N-butane. So I'm going to still do the lab 2. So I'm doing copy lab 2. I'm doing group 1. So it says GI, I stands for your group number. I do group 1. This time I say new dot, still lab 2, LA2 setup dot par, and then I say the lab. Okay. So when I do this, now what I have is only 1 cc. So if I look at the composition of this, still I have N-butane. So still I have N-butane, 100% liquid N-butane. Okay. I look at the pressure. So I open valve 8. The pressure is 2000. So the pressure is correct, 2000. I had 100% liquid N-butane. I didn't have any CO2. The temperature is 71.6. The only thing is, instead of 10 cc's, now I have only 1 cc. Okay, and I just hope to, with the 1 cc, I will be able to find the dew point pressure, but we will see. Okay, so for that, again, I'm gonna use the 10%. So I'll go here. Remember, this table is generated for 10 cc's of the N-butane. So now that I have 1 cc, all these numbers needs to be divided by 10. Okay, so this time instead of adding 0.57, I need to add 0.057 because this volume was calculated for 10 cc's of the N-butane. Now I have only 1 cc. So to do that, exactly like what it did before, I'm gonna open valve 9. I'm gonna open valve 11. I'm gonna open valve 4. And I'm going to remove minus, this time 0.057. Okay. Remember, this table was generated for 10 cc's of N-butane. Now that I have only 1 cc, so this numbers needs to be divided by 10. So now I'm going to close valve 8. I'm going to open valve 1. And I'm going to inject that 0.057 into the CO2. So now I had 1 cc, now 0.05 cc's of CO2 added. I'm gonna close valve 11. If it says gives me the bubble point, just give 2000 as an estimate. And then I'm gonna close valve 4. I'm gonna close valve 1. I'm gonna open valve 8. Everything is in order. And now I'm just gonna shake this out. Okay, so to just double check, if I press F10, now I wanted to have 10% CO2. I have almost 10%. I have 9.4, and I have, instead of 90%, I have 90.5% of N-butane. So I'm close enough. Okay, so I have my mixture. Now I need to find the dew point. I don't worry about the bubble point because I already got the bubble point for this mixture. That's 32.569. So I don't worry about that. So I'm gonna find the dew point. So I need to convert all that liquid to gas. So I'm gonna remove minus 20 cc's. So I remove 20 cc's, still I have 0.8. I need to shake the cell, so I shake it. Remember here, the idea is to convert all the liquid to gas to get to that 0.001 cc's of the liquid, okay? And remember, this hand pump has only 30 cc's, so I'm going to remove another 9 cc's, okay? I'm going to shake the cell. So still, I have a lot of liquid, but this hand pump is almost full. So I'm going to close valve 8. I'm going to open valve 10. I'm going to empty my hand pump, because hand pump only has 30 cc's. So I got 20 cc, 29 cc's, almost full. So I'm gonna close 10 again. I'm gonna open 8 again. And I'm going to remove another, let's say 30 cc's. And I'm going to shake the cell. So I do another 30. Still, I have 0.4 cc's of liquid. So again, I need to close 8, and I need to open 10, and I need to inject that 30 cc's. I need to empty my hand pump. So I'm going to close 10 again, open 8 again, and I'm going to remove another 30 cc's. I'm going to shake the cell. Okay, so again, the hand pump is full. Just remember, we cannot just, if this if this visual cell goes empty, then you cannot continue the experiment. So that's the amount of mercury has left, and that's the maximum amount of mercury that we can remove. So I'll do one more time, and that's basically is the closest I can get. So I'm going to empty my hand pump again. I'm going to close 10. I'm going to open 8. And I'm going to remove minus, let's say, 10 cc's. See, so 10 cc was too much, so basically the fluid came out to the system. I got error. So the closest pressure that I could get was actually before this. It was like 24 something. So that's the closest that I can get to the dew point. So I know at this point the pressure should be around like 24, 20 something to be able to have the right number. And this is good enough. As soon as as close as you can get to the bottom of this, to the dew point, you just report it. Okay. So as you can see, even with this small amount of the CO2, just 1 cc, we couldn't able 1 cc of N-butane, we couldn't even get to the dew point. And that's why we basically use the definition of tie line to get to the point. So in the next video, what I'm going to show is to show you the full table that you can use for your lab report. Okay.